Welcome back to my channel Civil Zest. Today we will discuss some another important terms of soil mechanics and foundation engineering which I have already written on this board. So let us start. First of all, we have the definition of void ratio. Void ratio is a soil basic term which is denoted by the symbol E. E is the symbol of void ratio. And what is void ratio? Ratio of total volume of voids to volume of soil solids is called as void ratio. Now once another time we also explained, like the last video, that in the soil structure we have two things. These are our soil grains or soil solids or soil particles. You can say that these are the grains, soil grains, and these vacant spaces are called as voids. So there are, in the soil structure there are two things: grains, soil particles or soil grains, and other things are voids. Like in the last video we have discussed some soil basic terms like unit weight, specific gravity. Similarly, in this manner we continue this process, and we will search about the definition, some more definition. So void ratio is the ratio of total volume of voids to volume of solids. Means the total volume of voids we can calculate to the ratio of volume of voids to the volume of soil solids. Means the ratio of voids to the solids is known as void ratio E. It is noted by E is equal to VV divided by VS. Here VV is denoting the volume of voids and VS is the volume of soil solids. Next, the similar resembled term is the porosity. Porosity is denoted by N. Its symbol is N. The ratio of total volume of voids to total volume of soil is called porosity. N is equal to volume of voids divided by volume of soil. Now all these terms are related to each other. These are similar in formulas and equations, but we have to understand, to remember, that if it is the ratio which two kinds of our terms. So basically when you can see that in the void ratio there is a ratio of volume of voids divided by volume of soil solids, but here it is a ratio of volume of voids to the volume of total soil. Means in porosity we use the ratio of the total volume of the soil, but in void ratio we use in the volume of soil solids in denominator. So basically this is the difference to remember, that where we are using the volume of soil solids and where we are using the volume of total soil comprising the voids plus soil grains. So next, after void ratio and porosity, these both are interlinked, and we will see in next video that how they are interlinked with each other with the help of equations. Next, we will see the degree of saturation S. Now, what is the degree of saturation? Its symbol is S. Its definition is ratio of volume of water VW in a given soil mass to the total volume of water is called degree of saturation. Means degree of saturation, that how much the soil is saturated with water. It means that how much the soil is fully saturated or absorbed the water. So basically, if we have already studied that the soil has the two-phase diagram. In the two-phase diagram there is soil solids at the bottom, and at the above there is water. So basically this is the two-phase diagram, and in this two-phase diagram we have fully saturated soil. This diagram is representing the fully saturated soil because all the voids are filled with the water and there is no air in the voids. There can be two things in the voids: air and water. In case of fully saturated soil, the water is saturated up to its fully limit, and it's is represented by two-phase diagram. So here we can say that ratio of volume of water in given soil mass to total volume of volume water divided by volume voids is simply the degree of saturation. Now one thing you also can see, that dry soil S is equal to 0, fully saturated S is equal to 1, because we have volume of water. If we have VW is equal to VV, it will happen in which case? When all the voids are filled with water and we have the case of fully saturated soil. So then we both the ratio we cancel and we get 1. So in this case we got 1. Therefore I have written dry soil S is equal to 0, and fully saturated soil, our degree of saturation is 100% or 1. We can express degree of saturation in percentage also. So basically it can be 100% and it can be 0%, because dry soil is, in the dry soil all the voids are completely filled with air. Next is the concept with percentage air for air voids. So like other terms, you can also see the definition. First of all, it is represented by N or eta A. Na is the symbol of percentage air voids. Ratio of volume of air voids to the volume of soil mass, and is expressed in percentage. So basically, first thing is that it is the ratio of volume of air voids to the volume of soil mass. So volume of air voids is used in numerator, and volume of soil, total soil mass, is used in our percentage air voids. So basically, V divided by V multiply by 100, because it is always expressed in percentage. There are some units, there are some terms which are always expressed in the form of percentage, and like unlike one of them, there is percentage air voids, which as a name is showing, we also use the also express it in the form of percentage. That's why we will use multiply by 100. So it is VV divided by V into 100, and all the voids are filled with air. We consider them in this case. So after the percentage air voids concept, we will study air content is in another term similarly related to the air voids. If we see its definition, it is represented by AC, and its definition is ratio volume of air voids to the volume of voids. To the volume of voids is called as air content. So basically, it is the ratio of volume of air voids to the volume of voids. Now, it is representing that how much there are air voids in the soil sample, or we can say that how much the air is filled in the voids. It can be partially saturated soil, and it can be voids are filled with water and air. But out of all the voids, how much the voids are filled with air and how much are filled with water. So we have to calculate the air content, that among all the voids which are filled with the air. So basically, this is the concept of air content AC. If we see its definition, equation AC is equal to VA divided by VV. Another important equation is VAC is equal to 1 minus S. AC is our air content and S is our degree of saturation. Now this equation can be derived, but here I have written the equation that AC is equal to 1 minus S, and it is one of the important equation to solve the numericals of soil mechanics, like from this topic. So you can also remember that simple equation AC is equal to 1 minus S. Next in our last equation, next in our last term is density index. Density index is what ratio of the difference between void ratio in its loosest state and its natural void ratio to the difference between the void ratio in the loosest and the densest state. No, it is some bit difficult to understand its definition, but we will understand it by its equation. Basically, it is saying that it is the difference between the void ratio and its loosest state. Loosest state when the soil is reached to maximum void ratio. When there is maximum void ratio, then we call the soil to be in the loosest state. And oppositely, when there is the minimum void ratio, then we call the soil is in densest state. So when the void ratio is maximum, then the soil will be in the loosest state, and when the soil ratio is minimum, when the void ratio is minimum, then the soil will be in the densest state. Now first of all, you have to understand that it is the ratio of the difference between, you can say its equation, id is its symbol, id is the symbol of density index, is equal to Emax minus E. Emax minus E means it is a difference between void ratio in its loosest state. Loosest state, I have already described that it is E maximum, maximum void ratio, and its natural void ratio. Natural void ratio, which we have already studied, normal void ratio, which is denoted by E. So basically, in the numerator, we have this term E max minus E, loosest state minus normal void ratio, divided by 2 the difference between the void ratio in the loosest and the densest state. Now loosest state is E max, loosest state is E max, and densest state is E minimum. Densest state when we have the minimum void ratio. So basically, this is our denominator, E max minus E minimum, loosest state minus densest state void ratio. So this is ID. ID is our density index, or it has another name, relative density. It has another name, relative density. So basically, what is, we revise that density index, it is a ratio of difference between void ratio in its loosest state and its natural void ratio. Means it is the difference between natural E max minus E to the difference between the void ratio in the loosest and the densest state. No, here we have to, it is a statement of the density index. Here we have to understand that when our void ratio is maximum, then our void ratio, then due to a maximum void ratio, our soil will be in the looser state. But when the soil is dense and there are less voids, then our void ratio will be minimum. And from these all these values, we will calculate density index or relative density, which will be used in our numericals of this topics of soil mechanics. So guys, if we sum up this topic, that we have studied six basic terms of civil engineering soil mechanics. First of all is our void ratio E, which is E is equal to VV divided by VS, volume of soil, volume of voids to the volume of soil solids. Next is our porosity N, which is the ratio of volume of voids to what total volume of soil. Now in porosity we have total volume of soil, and you can also remember that porosity has all the V's in the formula. You can say V. There are three V's in the formula, so you can also remember that in the porosity we have all three V's, and it is a total volume voids to the total volume of soil. Similarly, degree of saturation, volume of water divided volume voids, and in case of dry soil S is equal to 0, in case of saturated soil S is equal to 1, fully saturated soil 100% degree of saturation. Similarly, percentage air void we have studied, Na is equal to Vv divided by V, and it is expressed in percentage. Air content, AC is equal to Va divided by V, volume of air voids to volume of voids. Here also here the volume of voids is used in the denominator. AC is equal to 1 minus S. It is an important equation, and we have studied about the density index and what it is. So guys, hope you understand the concept of these all six terminologies. If you understand this concept and like my video, then kindly subscribe my channel and like my video. We will meet in next video. Thank you and Allah Hafiz.